which I'll talk about when we get into the variable rate application, but if you're just looking at a tank mix, where I have just one tank, that's somewhat limiting in there to change that. I have a limited range. Now, sometimes that range is effective, and we'll talk about when we get into decision support, what's going to change in the field. Why would I need 5 gallon per acre somewhere and 10 gallon per acre somewhere else? We'll talk about those logistics. Now, I'm moving into, so I just wanted to share that with you. Any questions do you have on your lab? Because I'm going to move into a situation that is going to quiz me, and you guys have been quizzed. Now, I'm going to develop a problem to quiz me, and I want you to see how I work through that problem, or I want you to help me work through that problem. So, any questions you have on assignment 3? As you're moving through there, due Tuesday. So, the problem that I'm going to run in, that I want to solve here, is one in which we have a sprayer set up. We have a sprayer set up, and we are attempting to control its operation to a desired rate. I have TK2s, and I have a 36-inch space. What we have. And I'm traveling at 6 miles per hour. And I want to put on my desired application rate is 8 gallons per minute, gallons per acre. That's my application rate. Not a flow rate, gallons per acre. That's what I want to put on. What pressure do I need to be operating with? Okay. Test question for Dr. Harris. That's my nozzle. That's my spacing. That's my speed. That's my desired application rate. What pressure do I need to be operating? How do I solve that problem? Because that's what a control system does. I forget what page that's on, but we get into variable rate controller, which I'll talk about here after I finish this. Example starting on page 95, components of all variable rate applicators. That's what a variable rate controller does. It says, what's your desired application rate? It knows this stuff. It knows this stuff. It measures that stuff with some sort of sensor in the field. We'll talk about velocity sensor. And it controls my pressure, which you really don't know how, but we'll talk about that, to get me that. And that's the desired application rate for that location in the field, for however it was determined. So, what's my first step? Oh, God, that's right, it's my quiz. Okay, well, my first step is the application rate equation. Okay, we know that the gallon per acre in 5940 times my gallon per minute divided by my velocity in miles per hour times my nozzle spacing in inches. You should remember that equation. Remember that. Now, in the text, it also has it reversed, where you can put gallon per acre is equal to. And all it's doing is taking this, or gallon per minute is equal to this, and all it's doing is taking that equation and changing it around. But I just remember one style of it. You can get to the other stuff. Okay, so if I'm taking a look at this, then I'm going to say, well, my gallon per acre is equal to 10. Wrong. 8, thank you. Minus 5. Down to 95. Okay, down to 95. Keep track of my score on this. I'm down at 8 gallons per acre. That's my desired rate. 5940 is that conversion. That converts all the units that I've asked you to make sure it's right. That's an interesting exercise in itself. Times my gallon per minute. Well, what's my gallon per minute? I don't know that. Okay, so let's just put gallon per minute. I've got to figure that out. Divided by my velocity in miles per hour. Oh, I know that. It's 6 miles per hour. Times my nozzle spacing in inches. And now this is kind of critical because this is the nozzle spacing between individual nozzles. I haven't put up here how many nozzles I have. 4 nozzles, 2 nozzles, 3. That's not important at this point because I'm interested in the pressure. I'm going to throw a statement out here. If I was projecting what's the flow rate through my flow sensor to do this, then I'd have to look at the number of nozzles. But now I'm just looking at the pressure. So my nozzle spacing is 36 inches. Now here's where I run through all this analysis and I say, okay, I can figure, and this might be something that you might want to do with your calculator. You might be doing this again sometime. Is what is my gallon per minute out of each nozzle? Individual nozzle. If I put individual nozzle spacing in here, I'm looking at the gallon per minute for one nozzle. All right. Anybody got an answer?
Came up with 0.29.
0.29. 0.29 gallon per minute. Oh my gosh.
This is kind of good.
Remember, it's not liters per minute, it's gallons per minute. Anybody else get that number? Yeah. Confirmation. We have confirmation. 0.29 gallon per minute. Well, that seems a little reasonable to me because if I throw it, no, I didn't throw it there. Because if I take a look at that nozzle, the TK2,